Thank you. Thank you very much. So just before starting, I would like to say thank you to the organization committee to invite me here to present our re-irradiation experience. So I just I will give you present my experience. But before that, I would like to clarify what is re-irradiation and what did we understand from the re-irradiation. So I have no disclosure. I would like to start with the terminology of the re-irradiation, and then I will give you some challenges about the re-irradiation. Re-irradiation is a very difficult area, so we should be very careful as a physicist. And then I will give you some information about the dose constraint we used in our department and generally used in all over the world. And then I would like to give you some real patient data about our department. So I'm working in one of the private hospitals in Turkey, which is affiliation with the Johns Hopkins. So we are inviting a lot of patients from the abroad, which means that the patients are treated in outside for the primary treatment, and then they are coming to us without any report, any data for the primary irradiation. So we have a lot of cases about the re-irradiation. That's why we would like to create a workflow for the re-irradiation. So I would like to give you some information about our workflow. But before starting, let's understand what is the re-irradiation. So re-irradiation is very common. So you should use a second irradiation. It should be a retreatment, and it will be, and also the previously irradiated area potentially affected from this irradiation, and you should have a previously irradiated treatment course, which is called re-irradiation. But there are some clinical scenarios. Think about these clinical scenarios. As a physicist, probably you will see this kind of scenarios. So this is the first scenario. There's a primary irradiation, and then if you want to irradiate the second one, the PTV is fully matched. This is the first scenario, and the second scenario is quite different than the other one. There's the first irradiation, and then you have another irradiation, but the PTV is not fully covered for the first irradiation. You have a partial irradiation. So this is the second scenario. And the third one is a little bit interesting. You have a first irradiation, of course, but you have another irradiation which is not affected. There is no any match, but still in the same organ. So you are irradiating the same organ. So these are the clinical scenarios. So these scenarios are very important. So the reason is that, let's move to other slides, because if you have a first and second scenario, which means that the PTV is completely or partially matched, which means that your maximum dose is very important, because we need to be very careful for the serial organs, and always the doctors are concerned about the toxicities. If you have a third scenarios, and then cumulative dose is very important. Distribution of the cumulative dose is very important. So you should be taken account to the parallel organs. So this is the parallel organ dose. I mean the volume dose is very important, and of course you should have high toxicity if you exceeded the volume dose values. So let's go about the terminology first. So we understand the re-irradiation, because re-irradiation and the retreatment are sometimes mixed. So there is a very good study, and there is a good consensus. They published the first consensus, which is called the Delphi consensus. They published last year, and according to this consensus, so if you will ask some question just before the planning to the patient. So the first question, so you would like to plan a new course for the patient, and then you should ask the first question. So the first question is that, what is the first question? Is there any geometrical overlap between the two PTV volume? If you have a overlap, which means that you have a re-irradiation type 1. So what is re-irradiation type 1? The re-irradiation type 1 means that there is an overlap, and you doctors have a concern, or with or without concern, about the toxicities and the primary dose. This is very important. If your question is no, and then you will go to the second question. So the second question is that, is there any concern for toxicity from the cumulative dose? So when you sound the dose, do you have any concern about this dose? If your question is yes, which means that your irradiation type is type 2, which is there is no overlap. To think about the scenario 3, and then there is a concern for the toxicity from the cumulative dose. So we should take into account the volume dose. If your question answer is no, and then you should ask you again another question, which is third one. The third question is that, are the target volumes are current and the previous radiotherapy located in the same organ or not? If located in the same organ, which means we call it repeated organ irradiation, not the re-irradiation. So repeated organ irradiation means that there is no overlap, no concern for toxicity from the cumulative dose, and the PTV in the same organ. So we understand that this is a repeated organ irradiation. If your question is no, which means that you are doing a repeated irradiation, and then which means that your second volume is completely outside to the volume of the first organ, which means that there is no overlap, there is no any concern for the toxicity because you are irradiating completely different organ, and then PTVs are in a different organ, which means that you can safely do this kind of irradiation. So we should concentrate on of course, the re-irradiation type 1 and type 2. And sometimes if you have a toxicity problem, you should be maybe also, if you don't have any toxicity problem, maybe repeated organ irradiations could be important in the clinical scenarios. So let's go to the clinical challenges. So what kind of clinical challenges we have? We have some clinical challenges. I will give you some information about this, and then I would like to give you some information about the radiation workflow in the department, and then I will give you some technical challenges. So look at these studies. These studies are re-irradiation studies. So if you look at these studies, about brain, breast, head and neck, lung cases. So if you look at the toxicities, there are some patients have, in the line. Sometimes there is a 3 patient. In other, there is a breast case 4 patient, and there is a lung case in the down, and there is a 24 patient affected from the grade 3 toxicities. So which means that if you are doing a re-irradiation, you should be taking account to take toxicities, which means that you should be careful for giving your dose to the proper area. So what about the clinical problems? So the first problem is the location of the recurrence, so or second tumor in the relation for the primary tumor. So connection between the first tumor and the second tumor relation. The second one is the previous radiotherapy information is very important. So you should know that the first treatment properly. And also the patient other treatments like concomitant treatments, surgery, or whatever. So you should know that the previous treatments could be important for re-irradiation. And I think the important one for the physicists is the time since treatment of the first tumor. So between the 2 tumor is very important. And the treatment intent. So why you are doing this? Is a curative care or it's a palliative care? So these are the clinical scenarios you should be taking account with the doctors. And there are some, I see some AI studies here, and also there are some machine learning based models are predicting and also classifying to the this kind of toxicities now. So if you have this kind of machine learning products, so you will put the inputs inside and you will see the results of the toxicities. This is very helpful for the doctors, of course. So what about the workflow problem? So you have a patient in the department, you would like to treat the patient, but you have a really major problems if you are treating a patient secondly. So the first thing is that I think in our department, we are really very difficulties to collect into the prior treatment data. So information from the primary sites, you should ask the DICOM data, which is very helpful for you to plan to the secondary radiation. But sometimes you cannot reach this DICOM data, and then you will get to the printed PDF, of course. But printed PDF sometimes limited, give you some limited information to us. Maybe if you don't have, because we are really calling a lot of patients from the abroad, and sometimes we are doing a replica plan, copy of the plan. Just imagine, just understand the dose value, and then try to evaluate the replica plan. So this is maybe helpful to you. So you can do this. This is something about the prior dose information. And what about the doctors? So that physicians have great. The physicians need some, of course, taking account or take attention for the re-irradiation. So what they will do, they will specify the history. As a physicist, I cannot find the values of the patient prior data. So they need to be specify the history of the radiation first, and then they should think about the intended dose and also the number of the fraction. This is another mission for the physician, I think. And then they should think about the risk assessment. So they think that this second radiation will be feasible, and they will think that this will be beneficial for the patient and with the low toxicity. This is another important thing. As a physicist, So we should do something just before the planning. But what we can do, we can review the records. This is very important. If you have a DICOM data, you should review this DICOM data. And then we should, assess the remaining dose. This is another important thing, I think. And I will show you how we are assessing in our department in the end of my presentation. And then we should know the recommended dose limits for the re-irradiation. And of course, we should be in the decision-making process. We should help the doctors to deciding the patient treatment. And I think the last thing is that post-planning evaluation. This is also another important thing, I think, because we should sum the dose, because we have two different dose information, and we should sum the dose and then review the composite dose with the doctor. I think that this is another important thing for the physicists. So just move on more. I cannot move. Yeah, now, okay. Let's go to the technical problems. I think one of the technical problems is the composite dose assessment. So I think the first thing is that image registration. There's two things I think is important. Two important subjects is important in the image registration. So do we use a rigid or deformable registration for the both sides? Some people are using a rigid and some people are using a deformable. Sometimes deforming the image is a problem because anatomy is completely changing. So we should be understand case by case or maybe side by side which kind of registration we will do. And another thing is, I think, what kind of registration we will do. We will use a multi-segmental registration, or we will do an organ based registration. So maybe we should think about the case by case with what kind of image registration we will do. This is one of the important technical problem. And another problem is the dose recalculation. I think these formulas, of course, but the problem is that there is some biological dose formulas, there are some physical dose formulas. So which is the effective one? Do we use a two equivalent quadratic model, or do we use a BED model? So we have really problem for calculating the dose here. And another problem is that do we use a biological corrected dose, which means that do we need to discount the prior dose or not? Using a time scale. And another problem is that alpha beta value. If you look at this is one of the important things. If you look at the literature this is only for spinal cord, there are lots of studies about alpha beta value and different values. So which value we will use for the organs? So this is another problem for those doing a dose composition. So, and then another important problem is that are you calculating the serial organ dose or are you calculating a parallel organ dose? Because if you are calculating a serial organ dose, sometimes maximum dose is damaging to the whole function. This is a very important thing. And integral maximum dose is very important for serial organ. If you are calculating parallel organs, which means that the volume is important than the maximum dose. So you should be taking account of which organ you will calculate. This is important one. And sometimes smaller volumes. For the smaller volume, you will go to the large volume doses, which is not affected the organs, which is not affected the whole organs. So you should be taking account of these items while you are doing a recalculation for the dose. And another problem I think for the dose calculation is that recovery. So look at this table. This was reviewed by the Nieder in 2000. And they see that these red things, mesenchymal tumor, mesenchymal part, heart, and kidney, there is no any recovery that, and the evidence is very high. But if you look at the spinal cord, there is some recovery in the spinal cord, which means that you can discount some dose from the spinal cord. So these are the studies. So you should know that what kind of organs could be, what kind of organs you can do a discount and you cannot do a discount. So this is very interesting study. You look at this study. I think it's a very new study, and they asked the physicists, and they asked the physicists, what do you want from the vendors for the re-irradiation? So I'm a physicist. So what I am asking to the vendors to provide me for the re-irradiation, and if you look at this. The maximum score is, calculating and visualizing the 3D dose distribution in EQD2, which means that, the physicists, try to find a, software which is calculation, which the software is doing a EQ2 calculation or BED calculation, and giving us the alpha beta value with recovery, data. So which means that the physicist needs to be solve their problem with the software. So this is the maximum score. If you look at the minimum score, they need to ask some rigid registration softwares. Probably lots of physicists now have a rigid registration algorithm, which means that they don't need some rigid registration algorithm. So this is the minimum score. So they will ask to the people, to the vendors, maybe there are some vendors here, to create a software which is calculate the AQD2, alpha beta value, recovery value, BED value. So this is the important messages from the physicists to the vendors. So okay, so we know the problems about the reirradiation. What about the dose constraint? What will we use in our departments? So there are different studies, but the problem in the dose constraint is that look at these 4 studies, and they put the alpha beta value is 2 gray. But if you look at the spinal cords, there are different data here. There are some studies using the max values, some studies are using a 0.1 cc, and there are different Dmax values for the spinal cord, which means that there's a huge variation between the studies. So we need to decide which study is effective and which one is not. So another important thing maybe, as a physicist, maybe you can follow some studies, some evidence-based studies. This is another thing, but you should be taking account that there are different dose tolerances for organs in different studies for the same region. So what about our experience? What we are doing in our department? So we have 2 different forms. The first one is a general form we are using in our department, which is giving us some values, and this form is created and copied from the Parotis et al. They published it in 2019, and it's really a very good form because it's really how can I formalize to the reirradiation, and it will give you a dose reduction according to the time between the 2 irradiation, from lower than 3 months if the reirradiation is between the 3 and 6 months, or between the 6 or 1 year, and also between the 1 year and the 3 years. So they will give you some information about the discount, which is very important for me because I can use this table. I will give you one example about our cases. And another thing I think maybe we are using for site-specific form. For example, for reirradiation for the prostate, there is no any evidence-based data anymore, or very low data about the reirradiation for the prostate. So what we are doing, we are using a fuller protocol for this. They published it in 2020, which is the only dedicated for the prostate reirradiation, and they have some table, and they have some they have very huge data, and they have really a very good results, which means that I can use this table for prostate reirradiation. So I have a site-specific form also in our department. And also these forms are affected from the MME's values, Quantec, and really HITECH is a very important, publication for the reirradiation. So you should check this, data while if you are establishing a, reirradiation in your department. So I will give you some, real data about our department. So this is the first case. So we irradiate this patient in March 22, okay, and we give 3 gray, and the total dose is 16. We use variant H system in this patient. As you see here, this is the low dose distribution, and then the second irradiation just only 1 year pass, and we treat this patient secondly in the same area with CyberKnife. We give 5 times 6 gray, and then we composite this dose with the velocity. We have a velocity in our department, and velocity calculated AQ2, and then we evaluate the dose. We follow the one of the protocol for the brain because there is no any brain stem here, no any critical structures here. According to the literature, we should be within the, we should be brain composite dose not to be exceed the 113 gray, and according to this, formula, AQD2 formula, our dose is 108, which is under the 113. So I accept this dose, and I just told my doctor that brain necrosis could not be happen for this case. And the second case, again for brain, but this time the problem is that there is a optic aperture here, and also the brainstem also here, which means that I need to be taken out. I should be careful for this. So we give 60 gray for the first one, and then after 3 years the patient came again to us with the local recurrence. We give 5 times 6 gray with the CyberKnife, and then we composite those, as you see here, like with velocity again. And then there's a problem for the brainstem because the total dose is exceeding to, and also optic chiasm dose and optic nerve dose are very high. We didn't apply any recovery calculation, and we used this form, general form we use. And if you look at this form with reduction, if you use the reduction, you can easily see that your tolerance values are under the tolerance for the brainstem and the other organs also. Just before the lung cases. So this is one of the case we read it in the variant H, and then after 2 years you see that another local recurrence in the same area. The doctor just prescribed a 10 times 3 gray for this case. Then spinal cord and esophagus is really very important in this case. So what we did, we just composite those in velocity, and we checked the dose. If you are not, applying any recovery calculation here, you see that the esophagus dose is quite high and acceptable. Also, spinal cord dose is the same, but 20 months between the two treatments, which means that I can apply to the reduction according to the Paratis et al. Literature or published data. And then when I apply this reduction, it is in 64 gray for the esophagus, which is under the 17 according to the literature, and also spinal cord dose is 45 gray, which is under the 15 gray, and I accepted those. And the last slice is for the prostate case. For the prostate, it's quite important to because to get the data maybe, but we don't have any data for this case because the patient was irradiated outside of Turkey 5 years ago, and we don't have any DICOM data, no report, just only we know the dose for this case. And then we use the CyberKnife again. What we are doing, we are using a fuller protocol, which means that we are creating a brachytherapy light dose in CyberKnife, which is a very heterogeneous inside, but also we are protecting the urethra. So after 5 years, we give 5 times. Total dose is 34 gray with CyberKnife, and then we use the fuller protocol, and we fill the dose here, which means that we are creating a rectum outer wall, inner wall, and the bladder volume, and the rectal dose, and we checked their maximum dose according to the Reirradiation data. So according to your site, you should create your form, and you can follow this form, which is supported by the literature. So thank you very much for your attention. Any question?
Yes. Another